Hi everyone, welcome to the logical programming session 4. In today's session, we'll be doing bit of problem statement, basic ones, not the pattern questions, but small basic programming problem solving questions where we'll see how to write program. Now remember one thing, solution for the problem, golden rule. If you understand the problem statement, 75% to 90% solution is done. Now remaining percentage is just writing the code in a programming language. So problem comes, people do not understand what is a problem statement. Now if we start understanding the problem statement, the question, the solution is automatically you will be getting 75% to 80% solution is there in understanding the problem. So let's see how to go about. So we'll start with our first program for today. It says write a program to check for prime or not. Write a program to check whether a number write a program to check whether a number is a prime number or not. Now here first we have to understand what is a prime number. A prime number is a special type of number which only gets divided by itself or by 1. Now 1 is basically a special case. So let take a number like 2. 2 can be divided by 1 and by itself, no other number. 3. 3 can be divided by itself and by its number. So basically you say 4. So like number like 1, 2, 3, 5. So these are number which gets divided by itself or by 1. Now if you take number like 4, 4 can be divided by 1, it can be divided by 2, and it can be divided by 4 itself. So this is not a so this is not a this is not a prime number. Similarly 5, now 6. 6 will get divided by 1, 2, 3, 6. 7 only by 1 and 7. 8, 1, 2, 4, 8. 9 by 1, 3, 9. Similarly 10 will be divided by 1, 2, 5, 10. 11 only by 1 and 11. So this way we define. So the prime number is a number, a special type of number which gets divided by itself or by 1. Rest other numbers are. So if we see the pattern, if I have to see whether 6 is a number or not, so I'll first try to see half, a square root. You know what is square root? So first what I'll do, I'll try to create a square root, a number near the square root. So I don't have to go till, so if I want to traverse, so I will check. So if I say I have to check number is 4 or not, I have to run a loop. So if I want to check whether number 4 is, so I have to go for 1, 2, 3, 4, right? Because I have to run a for loop, and for each iteration of number, I have to check whether 1 is divided by 4 or not. Or I will not take 1 because 1 is a special case. So I'll remove 1. So I'll start with 2, 3, 4, the for loop, right? And every time I'll check whether the 4 is divided by 2 or not. Or I will not. So 4 again is an extreme condition. Every time the number 4 will number itself will get divided, right? So we'll not take 4 also. So we'll start with looping from 2 and we'll go number minus 1, right? So we'll say num minus 1, 2 to number minus 1. Now if it's 5, we'll go to 2, 3, 4. If it's 10, I'll get 2, 3, 4, 5, 6, 7, 8, 9. Now basically when you keep on increasing the number, the looping will become more and more complex, right? So if I take 1013, now 1013 I have to loop till at least 1011 time, because 1 will be out and last number itself will be out, right? So I have to optimize my looping, because if you see here, if I say 4, if anything divided by square root, so what is square root? Square root of 4 is nothing but 2. Try to add a half of the number. Now obviously 5 square root cannot be a whole number. It will be something like 2 point something something something. Now what we'll do, we'll try to loop half of the time, because if you do looping half of the entire, then it becomes optimized for a larger number. Now obviously for some number you might get a whole number, like 4 square root is 2 or 9 square root is 3, right? So you get a whole number. So if a 9 gets divided by 2 or 3, anyways, it's not a prime number. So I don't have to go for 4, 5, 6, 7, 8, 9. So what we can do, if a number is not a whole number, if it's a fraction number, so we'll round it off to the nearest whole number, right? So how does we write the program? We say for I equal to 2, I less than equal to square root of number and I plus plus. Now there the division and more. So here if I say uh, anything like divide, so when you say divide, in programming the integer division doesn't work like a maths division. So if I say 5 divided by 2, so what will I? 2 2s are 4, remainder is 1. So if I say 5 divided by 2 in programming, it will give me 2, the quotient as a value. And if I say, there's another thing called 4 mod of 2. So here 5 mod of 2 is 1. It says remainder. So we have learned 2 new operator. So it's not like normal maths. In normal maths, it would have been a different story. It would have been 2.5 as an answer because it gives you the fraction. But when you divide an integer or a double number, a whole number in programming, a division will always give you a quotient and modular function will always give you a remainder. So if I see here, if it was modular, if remainder is always 0, that means it's a divisible number, right? That's what maths tells us, right? So here what I'll do, if I mod, if a number gets divided by I and results into remainder 0, that means it's a divisible by 2. So if I say if number mod of I is equal to 0, that means it's not a prime number, right? Because we are not considering the extreme condition. We are not considering 1 and we are not considering the last number itself. So if in between, if it gets divided by any number, then we say number is not prime, and we break the operation there. So there's a break statement which breaks the loop. So from here, I don't want to go. If it's divided by, if any number is, if I take 4 as an example, and if it gets divided by 2, I don't want to go for 3 or any other number now, right? So I'll stop there. If it's a huge number like 1050, so I don't want to loop till half of that number also. If it gets divided by 2, 1050 gets divided by 2, I there itself tell, okay, boss, apart from 1 and 1050, it still get divided by 2. So it's not a prime number. So this is how we write the code. So first thing is we have to understand the problem. And when you understand the problem, you will get the solution directly. So we understood what is the integer, what is the primary number. Okay. We understood the concept of prime number. And then when we started doing optimization, because traversing the entire uh, range from 2 to number -1 will take a large sort of programming CPU usage. So we divided into a square root, nearest half. And from there, we started understanding if we get a number remainder in, if any division operation gives you a number 0 as a remainder, we say it's divisible number, and then we say it's not a prime number. So we'll see how to write a code. So I have already written a code in online Java editor. So we'll go through this number. So I've used double because when you do a square root always generate a double number. So we'll see. So double is nothing but a high value of integer. I've taken one boolean flag is prime, true or false. So I'd say it's false for timing. I take a number. If number is 1, if you input number 1, then we say it's a prime number only, right? We don't have to do any division and all, right? 1 is a special case. But if it's not a 1 number, then we first create a square root. So there's a function called math.squareroot, SQRT, which generates a square root nearest. It will generate the number, and that number will be a whole number. It won't be a whole number. It's not guaranteed that we'll get 2. It might get 2.5 or 3.2. So that what we do, we convert that number into an integer. So there are Java or any programming language nowadays do the internal conversion from primary types, double to int to double, float and all. So I got my square root. So now I'll traverse from 1, I follow from I equal to 2, and I'll go till the square root number digit, the halfway, and then I'll increment. If any point of time, if I find that number is divisible by the I iteration, then I'd say it's not a prime number and I'll make it break. And if it goes on traversing, I'll say it's always true, true, true. And then, or you can optimize this code by saying, hey boss, let's make prime true upfront. So there is no condition of writing an else statement. So it's true. If it gets into this condition, it will become false. And then we print it. So if I say 36, now 36 is divisible by many numbers. So 36 is not a prime number. If I write 31, oops, sorry. It says it's a prime number. So this is how we write the code. So this is a logic in Java. So anyway, C++, C#, any programming language fine. The main concept is to understand the how to write a solution, right? So now we'll go to the second question. Write a program to check whether input is alphabet or not. So it's a very simple problem to solve. So first again, if you say A to Z or A to Z or special character, you will say it's not a number, right? But when you input any number between digit 1 to 9 or anything, you say it's a digit. Now, for single digit, there is a data type called character. So we say CAR. So I say A this way. So it's okay. And most of the programming language has character dot is digit function. which says is digit, you put the input and it'll give you whether it's a digit or not. So when you say A, it'll say it's not a digit. But if I, instead of A, if I say 2, it'll give you true value. So most of our language has a character class or character function which decide whether the character is in digit or not. So we'll see the program. It's a simple program. So I'll comment this. We have written the solution for almost all the programs, and we'll see this. So I've inputted 8. I say it's number I've just created. If character dot is digit value, if it returns true, the condition returns, I'll say value is a number, else value is an alphabet. If I run this, it says 8 is a number. And instead of 8, if I say X, and if I run this, it will say X is a alpha. So here we understand how to write if condition. So you understood importance of if conditions and loops in programming, right? And that's the reason we started off writing patterns and all to understand when to use for such small problem statements. The third is to check whether the number is, to check original number equals to reverse or not. So if I, so let's understand this. Now this becomes a bit complex problem to solve. So we'll see how to solve it. So I say 1 0 0 1. Reverse of this will be again 1 0 0 1. 1 2 3 4. Reverse of this will be 4 3 2 1. So I say reverse, yes, it's same, not same. Now what we do, we have learned how to write division and modulus, right? So let's take one case at a time. So I say divide 1001 divide by 10. So I'll say 10 hundreds are, and I get remainder as 1. Right? So now I'll say remainder is 1. Okay. I'll create another number reverse, okay, which is equal to 0. And then I'll say what we can do with reverse is we'll say reverse into 10 plus remainder. So what is reverse? Reverse is 0 into anything into 0 is 0. 0 plus 1. So I got 1. So reverse is 1. And what is the question now? So number got reduced to 3 digit, 100. So my number gets reduced to 100. Now what I'll do? I'll divide 100 by 10. So I said 10 tens are 100. I got 0. Again I'll say now reverse is not 0. Reverse is 1 now, right? Reverse into 10. 1 into 10 is 10 plus 0 is again 10, right? So I got 10 as a reverse. And the quotient remains 10. So now I'll go 10 divided by 10. So 10 ones are 10. Remainder is 0. So my, now it's not 1. Now my reverse is 10. So 10 into 10 is 100 plus 0, 100, right? And then I'll divide 1 by 10 again. So I'll say zeros are 0, 10, 0, and remainder is 1. So here now my reverse is not 10. My reverse is 100. 100 into 10 is 1000 plus remainder is 1, right? So I'll say 1 0 0 1. Now I'll check if original number is equal to reverse, and I'll do this till I get number is less than. So if I once I get question 0, I'll stop. So I'll say while number divided by 10 is not 0, I'll continue doing this exercise of getting the reverse and remainder, reverse and remainder. Now if I do same thing with 1 2 3 4, so I say 1 2 3 4, so I'll say 123 times is 1230. I'll get 4 as a remainder. Reverse, so reverse is nothing but first it will be 0 into 10 plus 4 is equal to 4. Quotient is 123. So I say number is now again 123. I say 12 times 123. So here it will become 4 into 10 plus 3. So it's 43. Now I'll say 12. So 10 divided by 1, 2. So I'll say 43 into 10 plus 2. So I'll say 430 plus 2. It's 432. Now I say 1. So 10 divided. So it will be 4, 3, 2, 1. And so I'll check. Is 1, 2, 3, 4? No. So this is how we write the algorithm, right? So we are using divide by 10 and mod of 10. So what I'll do, I'll say, hey, number, I'll say reverse 0. I'll have another remainder 0, and I'll say original number equal to 1, 2, 3, 4. Okay. Now what I'll do, I'll say while number divided by 10 less than equal to 0, or I say not equal to 0. So till the quotient is not 0, so how do I not equal to? We say exclamation mark and equal to. So I first say remainder is nothing but num mod of 10. I'll say reverse is nothing but reverse into 10 plus remainder. And then I'll say number should be nothing but number divided by 10. So I'll start getting the reduced number. So again number will go from, so now here on a first iteration remainder will be 4. I get reverse as 4, number becomes 123. Is 123 divided by 10 not equal to 0? No. Again I'll get a remainder of 3. So 4 into 10, 40 plus the 43. I'll get number as 12. Number will go back. I'll get 2. I'll get 432 as a, and I'll get 1. Again it'll go. I'll get 1 as a number, and I'll get number 4321. Number becomes number divided by 10. So 1 divided by 10 is 0. Is 0 not equal? So, or you can write, instead of doing a binary operation, you can say, see, this is how you optimize number not equal to 0. Because what happens, every time the last statement will automatically reduce the number. And if original number we have stored here, and if reverse, so original, if it's equal to reverse, we say it's done. If not, it's not done. So we'll see this code. So nowadays I'm going a bit faster because now we assume that you have the understanding of basic programming. So now I have created 4 variable: number, original, remainder, reverse, all 0. I'll say number is 10112. Original is nothing but I'm storing the number, while number greater than 0 or not equal to 0, or sorry, greater than 0 works well, but not equal to 0, it will go in infinite, right? Remainder, I got mod of 10. Reverse, I'll start multiplying by 10 plus remainder, and number I'll start reducing one digit. If both are same, we print they are same. If not, so when I run this, it'll say 1012 is not equal to reverse 21. And if I say 1010, it'll say is equal to its reverse 101. So you understood. Now you got to know more about division and modular. So this becomes a bit more complex, but then these are very basic problem solving programs. So try to understand how to solve a program, and that will help you to get into more and more. Now, right, let's see how to print this digit. Patterns. I've taken one more pattern so that you get more used to. So pattern is something like this: 1 1 1 1 1 1 1 1 2 2 1 1 3 3 3 1 4 4 4 4 5 5 5 5. So again, if it's a pattern, I always tell you to make a rows and column. It becomes easy for you to understand the grid. I'll go faster with the pattern type of question because now we are used to it. So I'll say I 1 2 3 4 5, J 1 2 3 4 5. So when I is 1, we print I one time. If I is 2, we print I two times. But if you see column, which are last two columns. So I say number of columns or row minus I. So if J is less than this row minus 1, we print 1, else we print I. So 1 is less than, so if I say number of rows is 5, 5 minus 1 is 4. So if J is 1, we'll print 1. If J is 2, we'll print 1. If J is 3, we'll print 1. If J is 4, we'll print 1. If, or you can say equal to also. If J is 5, now 5 is not less than or equal to, so we'll print I, it is 1. Now let's take 2. So if J is 1, 2, 3, we'll print 1. But number of rows minus 5 minus 2 is 3. But if it's 4 and 5, we'll print I. So 2. So 2 again. Similarly, so you saw the relationship. So number of rows or number of column, whatever you say, minus I. If J is traversing less than that, we print 1, else we'll print. So that's the basic logic. So let's see the code now. So I've taken 7 rows. So I'll traversing between I equal to 1, I less than equal to 7, I plus J will also be traversing that one. If row minus J, so it's a reverse. 7 minus J 1, right? 6 is 6 less than I. So I is, so we'll print I. So it won't print I, it will print 1. So it's a reverse. Basically, the logic which I've shown on a Jamboard is the reverse than this. So it will print 1 when this condition fails, which will fail till it reaches the I. So if I run this, you will get the pattern. Now, obviously, I told you, right, in Java, sometimes it creates, this editor just creates. So 1, 2, 3, 4, 5, 6, 7. Now, if someone, so this is how we write the logic. So in this session, we have learned few basic programs. Now, I want you to try out some programs on your own. So check this pattern. You have to write a code to print this pattern 1, 2, 2, 3, 3, 3. It's a bit complex than the standard star pattern. Now we have to go into a bit more complex. So this is like an N, but 5 star, then 4, 3, 2, and then there's a this way. So you have to print this pattern. Then a pyramid pattern, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is how it is, right? So you have to go column wise and then row wise. And then there is a typical star, but then you have to digit 1, 3, 5. So 1, 3, 5, 7, 9. So these are a bit complex pattern, but not that complex. And then you have this pattern, which you have to print. So these are the questions which you have to try on your own, and we'll see you in next class. Thank you.